Today we are learning what a discrete random variable is, what makes a valid probability table, and how to compute the big three: probability of each outcome, mean of a random variable and its variance. The difference between discrete and continuous is whether you are counting or measuring. To describe a discrete random variable, you start by saying the number of, like the number of students who think my jokes are tasteless, or the number of students who will fall asleep during this lecture. Two checks every time. Non-negativity of each probability and total must be 1. Some teachers try to be clever by omitting one entry from the table, and if you ask about it, they would just smile smugly and say, "You calculate that one." This is a binomial with parameters n equals 3 and p equals 0.5. The probability of a binomial random variable like this ending up in the test is 100%. Expected value, mathematical expectation, isn't a typical outcome. No single set of 3 tosses yields 1.5 heads. It's the distribution's balancing point. Over many repetitions of 3 tosses, the average number of heads converges to 1.5. So the expected value is a long-run average, not a one-shot prediction. Variance is the mathematical expectation of squared deviation from the mean. If you actually understood what I just said, congrats, you're fluent in statish. Please grab the marker and teach the rest of this lecture. If not, that's perfectly fine, as long as you can use the formula. This trick saves time and reduces algebra. Use it whenever squaring deviations from mean feels ridiculous. Basically, always use the computational formula. Correct answer is B. Roulette uses a variable ratio reward schedule. Wins arrive unpredictably. In behavioral psychology, that pattern produces the strongest, most persistent response because each spin carries the hope that this one pays off, driving dopamine spikes and the one more spin loop. Other options are not totally off, but not the main reason.